De hecho, ojo, porque esto es largo. Bernardo.
Ah, io poi devo già una voglia di studio. Ok, ora come insegnare la lingua insegnano, ma non con noi da insegnare. Ora insegnano. Ok. Hello everyone, good evening. I'm sure you all can see me by now. Um, there's a comment section just in case you want to ask a question. Okay, good evening everyone. Now, for those of you watching the live, do it to like and share with your friends so that they can participate as well. Okay. Now, if you're often pursue TME examination or nursing examination, this is an important topic in mathematics. Indices, it is one of the basics. Okay, so I advise you pay good attention, and I'll give time to ask questions, so make sure you are following up. Now, indices is a very important and short but interesting topic in mathematics. Okay, now for you to understand these indices in mathematics, you need to know what we call the laws of indices. Okay, so I'm going to start with the laws of indices. Laws of indices. Okay, but before I go into the law, let me quickly explain something. Now, in terms of indices, if we have, for example, a to the power of m, okay, now I just pronounce it as a to the power of m. Take note, this small number on top, okay, this small number on top is called the power or exponent. Okay, it is called the power or the exponent, and this number below is called the base. Okay, this one is called the power or exponent. So if I refer to a number, okay, while teaching as power or exponent, note that I'm referring to a number that is small on top of another number. Now the bigger one which is under is called the base. Okay, now using that or having that in mind, let us now go into the laws of indices. Now, the first law of indices, it is not something you have to cram, okay? It's something you have to understand. And you understand the laws by practicing multiple examination questions, okay? Now, the first law, I'm going to formulate it and put it in here simply because I understand it, not because I have crammed it, okay? Now, the first law is when we have x to the power of m times x to the power of n. Notice that we are having a base here and a base here. We're having a power here and a power here as well. What we are going to do, whenever you are having two numbers or two variables multiplying each other such that the bases are the same, okay, take note, such that the bases are the same, okay, x and x are the bases and they are the same. If they are the same and they are multiplying each other, I'm going to pick one of them. What then happens next? We are still left with the two powers, right? I'll pick one of them and then sum up both powers. So this becomes what now? M plus n. Okay, so we have x to the power m times x to the power n equals what now? X to the power m plus n. Here's what I'm saying. Let's say we're having 2 raised to the power 3 times 2 raised to the power 4. The bases are the same, two big numbers, right? We are going to pick one and then add the two powers. So that is 3 plus 4. Okay, that gives us 2 raised to the power 7. Very, very easy. Here is another easy example. 3 raised to the power 5 times 3 raised to the power 1 equals 3 raised to the power 5 plus 1. That is equal to 3 raised to the power 6. Now you might be wondering, what if the bases are not the same? We'll get to that. Okay, that is why we are following them sequentially, okay, from the easiest to the toughest. This is the first law. Now let us take law 2. Now for law 2, if we have x raised to power m divided by x raised to power n, notice that the difference between these two equations or these two expressions that I've written is that in the first one we're having multiplication and in the second one we're having division. Okay, now what do we do in this case? The bases are also the same, so we are going to pick one, x raised to power what? M. In this case we're having division, so we're not going to add, but rather we do what now? Subtract. Take note, we are subtracting the second power from the first one. So this is m minus n, not x to the power n minus m. N does not subtract m. Okay, we are going to remove the second one from the first one because m comes first. So in this case, the bases are the same, you pick one. Since it is division, we are going to what now? Subtract both powers. Okay, that is the trick behind it. Now let us now go to the next one. But before we go to the next one, let's take an example on this one, just like the first one. So if, for example, I have these same examples, let's say I have 3 raised to power 5 divided by 3 raised to power 1. We're having division, the same base. So we are going to subtract. Okay, we pick one base, right? And then we subtract the powers. That is 5 minus 1. Okay, this then equals 3 to the power of 4. Okay, from there you can now expand and get your final answer. It's very easy. Let us now try this one. So we have 2 to the power of 3 divided by 2 to the power of 4. Notice that 4 is greater than 3. It doesn't matter. Okay, we still have to subtract 4 from 3. So this becomes the same base. So pick one, and then we're going to have what now? 3 minus what now? 4. That gives us 2 to the power of minus 1. That is how problems like that are being tackled. Okay, now here we have law 3. Okay, there are various laws. Depending on the material or textbook you are using to study, it doesn't really change anything. Okay, I can choose to summarize these laws and give you as 11 or 10 or 12 or 15. Doesn't matter. Okay, depends on how in-depth I would like you guys to understand what I am teaching. Okay, now for the third law, we are going to do something slightly different, okay, from these two. Let's say we're having x to the power of minus m. X raised to power minus m. What do you notice about this one? X to the power minus m, we're having a negative power, right? Now take note, whenever we are having a negative power, okay, whenever we are having a negative power, it becomes the reciprocal of the whole expression without the minus. So whenever we are having minus as an exponent, okay, or a reciprocal, it becomes what now? Or a negative number rather, it becomes what now? Reciprocal of the whole expression. So what does reciprocal mean? Reciprocal means 1 over that number, or switch it upside down if it is a fact. I guess many of you are having some network issues, but if you can still see the board, kindly indicate in the comment section. The network is stable now, and I'm giving you guys time to quickly write out these things you are seeing on the board so that we can take the next set of laws on these other parts of the board as well. If your network is stable and you can hear me, I'd like you to indicate in the comment section that you are active. Okay, let us proceed to the next. Now for the next set, this is law 8. Okay, let us now go into law 8. Now I've talked about 7 important laws, okay, down to number 7, x to the power of 0 equals 1, okay. Now let us now go over to the next one. For law 8, remember you don't have to cram these things. For law 8, if we are having x to the power of m equals x to the power of n, okay, in this one we're having an equation. One side is equal to the other side. But what do you notice about this particular equation? For this particular equation, both bases on the sides are equal. Okay, x is equal to x. We can say x cancel x. Okay, because they are equal, hence m will be equal to n. Look at what I'm saying. Let's say we are given a problem like this: 2 to the power of x equals 2 to the power of 3, and we are asked to solve for x. How do we solve for x? Okay, we can say since both bases are equal, they can cancel out, which means x is equal to what now? 3. That is what it means. Look at another one that is slightly close or related to it. Let's say we're having x to the power of m equals y to the power of m. Both powers are the same on both sides of the equation. We can now cancel both of them, okay, and we'll be left with what now? X is equal to y. Here is an example that is similar to this one. Okay, let's say we're having 2 to the power of 3 equals y to the power of 3. In this case, not the bases that are the same, it is rather the power. Okay, so 3 can cancel 3 because they are equal. Hence, we're having 2 equals y, but we have to write y first. So y is equal to what now? 2. Okay, that is the trick. So basically, these are the most important set of laws. Okay, here we're having 9 laws that I want you to learn. Okay, how are you going to learn these laws? You can either choose to go through them, but the best way to understand and learn these laws is by solving multiple examples. And by solving examples, you get used to them. You don't just cram these laws. Okay, so let us take some solved examples on indices. Let us take some solved examples on indices. This is the point where you get your stationery ready. Okay, but before you start copying or putting down things, you should first listen. Okay, first of all, listen before you start writing these things down. All right, seems like this section is out of reach on the board. Okay, so I'm going to rewrite what is here below. Okay, and identify this place. So I'm going to write solved examples. Okay, we're having some solved examples. Now I have some examples here that I want us to tackle. I have some examples here that I want us to tackle. Okay, now the first question here is giving us 9 to the power of minus 1 over 2 times 81 to the power of 3 over 4 divided by 9 to the power of 1 over 2. Now, how do you solve a problem like this? Now, solving problem on indices is very easy. Okay, now whenever you're given questions that you know you have to solve using indices, you won't be asked solve these initial equations or expression. Okay, you'll just be asked to simplify. So if I to simplify this, we're going to make use of our knowledge of indices. Okay, what we want to do is first of all make these numbers the smallest way we can break them. Okay, in terms of we're going to write each base in such a way that they will have a power. There is no straight method of writing it. You can do any one first. Okay, as far as you are following the laws and you do it in such a way that it will make it easy for you. Okay, now in this case we can write 9 as 3 squared, right? So solution you can write 9 as 3 squared. Now there's already a power there, so I will still write minus 1 over 2. Okay, times we can write 81 as what? 9 to the power of 4, right? 3 to the power of 4 rather. Okay, so 81 is 3 times 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27, times 3 is what now? 81. So how many 3's do we have here? We have 4. So you have 3 to the power of 4. Okay, so you have 3 squared raised to the power minus 1 over 2 times. Now 81 is what? 3 to the power of 4. So you have 3 to the power of 4 always to the power of 3 over 4. Okay, divided by 9 is what? 3 squared always to the power of 1 over 2. Okay, now let's continue simplifying. Now for this one, remember the law. I told you when you're having a power outside, we're going to use it to multiply the power that is inside. So the power outside multiplies the power that is inside. Let's apply the law here. Okay, so you have minus 1 over 2 times what now? 2. So that gives you 3 to the power of 2 times minus 1 over 2. That is what we're having here. Okay, times. Now for this one, we're having 3 to the power of 4. Okay, always to the power of 3 over 4. We are going to expand the bracket by multiplying the powers. So you have times 3 over 4 divided by, for the bottom, open the bracket again. 3 to the power of 2 times 1 over 2. Okay, from here we can now simplify. 2 cancels 2, 2 cancels 2, 4 cancels 4. Now what are we left with for this one? 3 to the power of, there's minus 1 there, minus 1 times 3 to the power of what now? 3 to the power of 3 divided by 3 to the power of what now? 1. Okay, now remember this law. 3 to the power of minus 1, what do you get? Whenever you are having a negative power, it becomes what now? Reciprocal. So you see that each of the laws that are coming into play, you cannot just solve one problem using a particular law. You have to apply any law that comes along the line. Okay, so 3 to the power of minus 1 becomes reciprocal. That is 1 over 3 times what? 3 to the power of 3 divided by 3 to the power of 1. Now 3 to the power of 1 is same as 3. Okay, so from here we have 1 over 3 times, now 3 raised to the power 3 means 3 times 3 times 3. So you have 3 times 3 times 3 all over 3. Let's now divide. 3 can cancel 3, 3 can cancel 3, and we're left with what? A final answer of 3. That is how problems on indices are being tackled. Okay, you just have to know the laws and apply them. And remember, you cannot just know a single law and then apply it. You have to apply the laws as you solve along the line, and you apply them where necessary. Now let us solve a slightly different example. This one is also easy. Okay, this one is an easy question, and the question reads: simplify 9 to the power of minus 1 over 2, or rather 2 to the power of minus 3 times 16 to the power of 3 over 4 times 2 to the power of 0. Okay, we are going to apply the laws here. Now look at the law we are going to apply. Easy rule. Solution. If you'd like to attempt this particular question, indicate in the comment section right now that you'd like to attempt the question. Let me give you guys time to solve. So if you'd like to attempt it, indicate in the comment section right now that you'd like to attempt it, so I can give you time to solve. If I don't get any response, I'll assume nobody here wants to attempt the question, and then I will have to solve it myself. Okay, I assume that nobody here wants to solve, and then I'll do it myself. Okay, so I have to solve it myself. Now, for this particular question, we are still going to apply the rules of indices. Very, very easy. 2 to the power of minus 3. Okay, we are going to apply the law. Since we're having a negative power, what law comes into mind? The reciprocal law. Okay, so this now becomes 2 to the power of minus 3. I'm going to write the whole equation again, or the whole expression rather, times 16 to the power of 3 over 4 times 2 to the power 0. Now 2 to the power minus 3, okay, becomes what now? 1 over 2 to the power 3. Remember the law that we're applying here. Okay, any negative power becomes what now? Reciprocal of that whole expression without the minus. Okay, and then multiply by 16 to the power 3 over 4. Now 4, which is the denominator, can be used as what now? A root. The same one we applied here. Okay, whenever we are having a fractional power, this one becomes what now? The root. So this now becomes 4th root of 16 raised to power what now? 3 times. Remember, any number to the power of 0 is equal to 1. So x to the power of 0 is 1, which means 2 to the power of 0 is what now? Also 1. From here, we can now simplify. So we have 1 over 2 to the power of 3 is what now? 2 times 2 times 2 into 3 place. We have 2 times 2, 4 times 2, that's 8. So we have 8 times, okay, now the 4th root of 16, how do we do that? Okay, or another way we can actually solve this is by breaking 16 into the smallest possible number. I think that way is best to solve it and make it easy. Okay, 16 is 2 to the power of 4. That is 2 times 2 times 2 times 2. So we can write this as 4th root of 2 to the power of 4 always to the power of what now? 3 times 1, right? 2 to the power of 4 is 16. The 3 there remains there. The 4th root there remains there. Okay, so you have 1 over 8 times. Now let's take this one back. Okay, I think we shouldn't have brought it down. It would have been easier if we broke 16 into its simplest form, which is 2 to the power of 4 first. Okay, to make everything easy. So this can be written as 2 to the power of 4 always to the power of 3 over 4 times 1. No need to start applying or multiplying constantly with times 1 because anything times 1 is that same thing. Okay, so you have 1 over 8 times, now watch the trick, power outside multiplies power inside, right? So you have 2 to the power of 4, okay, times 3 over 4. Okay, so we have 1 over 8. Now 4 cancels 4, so I left with what now? 2 to the power of 3, right? Okay, so we have 1 over 8 times 2 to the power of 3 is what now? 8. Okay, 8 cancel 8, and we're left with what now? 1 as our final answer. Very, very easy. Okay, and in this question, that is option B. And for the first one, the answer is option C. So these are likely post-UTME and NOSI examination questions on indices. When you understand the basics, it is very, very easy for you to follow up and solve other problems. I'll give you guys some time to watch it and understand the solution thoroughly. Okay, I'll give you time and some minutes to understand the whole solution that is on the board, while I take some of these laws out of the board and I'll assume you guys have written them down so we can solve some more examples. Now if you are new to this channel, do well to subscribe and like the video, share with your friends as well. Okay, the more you share it, the more YouTube wants you to help other persons. Okay, so if you are new, like and share, and don't forget to subscribe. Also, there are other videos on the playlist that you might want to go through, okay, on physics, English, mathematics, and other science areas as well. Okay, so you might want to subscribe so you don't miss out whenever these videos come out. I'll respond to your comments now. After the live session, many of you will be able to go through the video again. Okay, I'll be uploading the video again just in case you need to go through the video. Okay, and then if you're having a question, drop it now in the comment section where I can see them so that I can respond. Okay, I believe you have been following so far. Let us now solve a different exercise. Okay, a different exercise. Now in this case, we are going to be solving for x. Okay, in this case, we are going to be solving for x. Someone is asking what subject this is. It is written on the board, mathematics, boldly written, mathematics. Okay, for post UTME and nursery students. These are likely examination questions. For those of you that have been following me on TikTok, you should know these things are what you are likely going to come across in your examination. Okay, just like those persons that have already written the JAM exam, you know what you are going to expect. Okay, so the third question on the board is the value of x which satisfies the equation 9 to the power of 2x divided by 9 to the power of 3x is equal to 3. Okay, the value of x which satisfies the equation 9 to the power of 2x divided by 9 to the power of 3x is equal to 9 to the power of 2x divided by 9 to the power of 3x is equal to 3. And we're asked to find the value of x. This is the first problem that we are going to find x. And for those persons that are having network issues, you don't need to worry. After the live section, it is still going to be uploaded on YouTube, okay, so that you can rewatch it. And then if you wish to help your friends, endeavor to like the video, like and share the video with your friends, like and share to various groups that have JAM students or post-UTM students or nursing students that are preparing for exams. Okay, that is the least you can do to help your friends. Okay, now let us solve this easy question on the board, especially for those persons that do not offer maths. If you don't have basic knowledge in mathematics, trust me, it is going to be difficult for you to pass questions like this when you come across them in the exams. Okay, very, very important. Very, very important. Okay, and if your network is really bad, you don't have to stress yourself. You can still view it. Okay, you can still view all of it later on. Now, let us solve this question. Solution. Let us solve this particular question on the board. Okay. Now, to solve this question on the board, you need to still apply the laws of indices. Now, let us do it this way. We are having two numbers common, right? But let's write the equation again. I like writing the equation first. 9 to the power of 2x divided by 9 to the power of 3x equals 3. Okay, these two guys are common. Okay, you should know that a divided by b is same thing as a divided by b. They are exactly the same thing, just written in different form. So if, for example, I have a to the power of m divided by b, or rather divided by a to the power of n. Okay, it is same thing as a to the power of m divided by a to the power of n. Remember the law that I gave you guys. Okay, if you haven't forgotten, a to the power of m divided by a to the power of n is same thing as this one. Okay, and what do? We can pick one base and then subtract the powers. We can actually apply the same rule here. So this is same thing as 9 to the power of, or let us rewrite it as this guy. So you have 9 to the power of 2x divided by 9 to the power of 3x. Notice that I am simplifying it. But if you know what you are doing by practicing multiple examples, you can actually skip this step. Okay, so this is equal to 3. Okay, so we then have 9 raised to power 2x minus 3x. 2x minus 3x is equal to 3. Okay, so for me, 2x minus 3x is minus x. So sorry for the delay, guys. I had an interrupted power. Okay, the power got interrupted, so I had to quickly switch. You should know the country we live in, and that's exactly the problem we face every day. Okay, so right now I will continue solving the other problems. So we are going to continue solving the other questions. Now okay, we're having some interrupted power supply and network issues. So I'll quickly solve this particular one and then I'll upload the other ones on YouTube. Okay, now the question we're solving, we stopped here, 9 to the power of 2x minus 3x equals 3. Okay, then 2x minus 3x. Okay, so we're going to obtain 9 to the power of 2x minus 3x is minus x, right? And that is equal to 3. How then do we solve from here? If I choose to introduce logarithm, it will work. But we've not done logarithm before. Let's assume we don't know logarithm. Let's now solve this problem. Okay, 9 to the power of minus x equals what now? 3. How do we break this down? We can break down 3. The reason we can break down 9 rather, the reason we want to break down 9 is so that we are going to obtain something such that we can cancel out on both sides because we have this law in mind. Okay, x to the power of a equals x to the power of b. X can cancel x, a is equal to b. So we want to make the bases the same so we can cancel out them and equate the powers. Okay, so we are going to have 9 is what? 3 squared always to the power of minus x equals 3. But before we do that, we have to expand the brackets. Power outside multiplies what now? Power inside. Okay, so that gives us 3 to the power of 2 times x. We have minus 2x, right? 2 times minus x is minus 2x equals what now? 3, right? So for me, 3 can cancel 3. What are we left with? Minus 2x is equal to what now? 1. From there, we're looking for x. We have to divide both sides by minus 2. So we have minus 2x equals 1. Dividing both sides by minus 2. Okay, minus 2, minus 2. Minus 2 cancels minus 2. So we are left with x is equal to, the minus can never stay in the bottom. Take note. We must never leave a negative sign in the denominator. Take it upwards. So that becomes minus 1 over 2. And that is the actual answer to this question. Okay, now for those persons that had issues watching this video from beginning to the end and encountered the same issues we both faced while dealing with the live session, okay, you notice that I was only able to solve 3 questions due to the fact that there was no network issues with some of you and interrupted power supply as well. So what happened is you can watch a full video on indices on my YouTube channel as well. Just go through the playlist, you find a full video on indices, okay, where I've taught it. And also this video will be uploaded. Okay, so if you are watching this now while the live is not on, it means this video has been uploaded for the live. Okay, so indices made easy. If you need more problems to be solved and if you need us to make these things more easy for you in your exams, okay, you might want to join our post UTME or our nursing classes where we teach all of this, not just mathematics, but all the subjects that we are going to offer or come across, including aptitude and general knowledge in our main classes. Okay, there is a discounted price, and in the next few days you also participate and learn from the other free classes that we're going to have. Okay, so if you need a more detailed explanation or classes to learn for your upcoming exam and post-UTME and nursing exams, do well to reach out to me on WhatsApp. The link is on my YouTube page, to my WhatsApp DM. Just click on it and then text me. Okay, and then if you also cannot find it there, if you are on the WhatsApp channel, kindly send me a message from the WhatsApp channel that you want to register for the post-UTME or nursing classes, and I'll register you for the class.